This video is going to go through a second practice problem for you using the quadratic formula to find the x-intercepts or the solutions of a standard form quadratic. So let's go ahead, and you can see this is the work we did from the previous question. Let's go ahead and scroll over, and I'm going to write question number 2. So question number 2, let's write another quadratic. And I'm going to go ahead and write this in function form. It doesn't make any difference, class. So let's say our example problem is f of x equals x squared. Let's say plus 2x. And how about minus 24? So we've got f of x is equal to x squared plus 2x minus 24. So it's a standard form quadratic. We can use the quadratic formula to find the x-intercepts or find the solutions. We know the x-intercepts are where y equals 0, so our first step is always to make sure everything is on one side of the equation. I'm just going to rewrite it where our quadratic is on the left. And we're going to set f of x equal to 0 because we know that y equals 0 for all x-intercepts. Next step, let's go ahead and identify a, b, and c. So in this case, a is equal to 1. Oh, sorry class, I shouldn't have started solving. You should be pausing at this point. Hopefully, if you are practicing your skills, pause. Try to find the x-intercepts of this quadratic using the quadratic formula. And then when you're ready, start the video again, watch the steps, and verify that you are doing them correctly and getting the correct final answer. So pause now. All right, let's go ahead and continue. I've already done the first step, which was to set the equation equal to 0, and we're going to find a equals 1, b in this case is equal to 2, and c is equal to negative 24. So now we can find our discriminant. Again, find the discriminant first, and it makes the quadratic formula a lot easier to work with. So we're going to find what is b squared minus 4ac. Again, class, I'm going to write this exactly the same way you would plug it into your calculator. We've got b squared, so we've got 2 squared minus 4 times a times c. And let's see what that equals. So I'll bring up our calculator, and I will go ahead and plug in the parenthesis 2 parenthesis squared minus 4, and then we'll put the a in parentheses, and we'll put the c value in parentheses and press equal, and we end up with exactly 100. So our discriminant is 100. The next step was to go ahead and write our x-intercepts. We're going to write it out and plug in all the variables so we have our the step right before our solution. So x is going to be equal to negative b plus or minus the square root of our discriminant, which is 100, over 2a. b is 2, so in our equation, our quadratic formula, we get to negative 2 plus or minus the square root of 100. And then the denominator is 2 times a, which is 2 times 1. So our final value of x is going to be negative 2 plus or minus the square root of 100 over 2 times 1, which is 2. Now the next step is just to see if we can simplify a little bit further. Is the square root of 100 a perfect square? So we will check that in our calculator. I think most of you know that answer already. Let's go ahead and clear this, and we will do the square root of 100. And when I press equal, if it's an integer, perfect integer, or an integer that means it's a perfect square, that means we can actually simplify square root of 100 to 10. I'm going to write the word yes, meaning that we can go ahead and simplify it. If that came out to some other number with a decimal, then I would say leave it as a square root until the very end. Okay, the next step is to write our solutions or write our final answers. X then has to be equal to -2 plus, nope, we don't have to write square root of 10 anymore. We've already said the square root of 100 is 10, sorry, square root of 100. We've already said the square root of 100 is 10, so it's going to be -2 plus 10 over 2, and -2 minus 10 over 2. Now some of you might wonder, can you flip those two numbers around? Can you do -2 minus 10 and -2 plus 10? Of course. Doesn't make any difference. The brackets mean that the x values of the solutions include those numbers. And normally we want the smallest number first and the biggest number second. But in this case, for this class, it doesn't matter if you put those numbers in a different order. So you can put -2 minus 10 over 2, -2 plus 10 over 2. And this means our final answer. So if that's what our x values are, so x is equal to, if we put those in our calculator, we will get -2 plus 10. Oh, one thing I missed here, class, that I showed you in the flip book that I'd recommend you do is get used to putting parentheses around the top numerator. The reason why is that will help you when you actually plug in the final solution in your calculator. In fact, if we go back to the first example, we should put parentheses there as well. Let me show you why I'm doing that. If we now use our calculator to solve this, then the way we're going to do it is we're going to do parenthesis -2 plus 10 close parenthesis divided by 2. Now the calculator knows that those two numbers are in the numerator. So our first answer is x equals 4. I should write that in green to match the color. Our first answer is 4. Let's take a look at our second answer. So now we're going to go ahead and clear this, and we'll say parenthesis -2 minus 10 close parenthesis divided by 2, and that is equal to -6. So our other solution, or our other x-intercept, is -6. So there is our final answer. We have found the x-intercepts for the next practice problem. You can go ahead and, if you're doing this all at one time, you can go ahead and go to the next video. We'll do a third and final practice. Oh, before I do that, little note here. Take a look at our discriminant. Our discriminant is positive, therefore we had 2 x-intercepts. So you can make a little note in on your work that if the discriminant is positive, then the number of x-intercepts is going to be 2. So positive discriminant, x-intercepts, there's 2 x-intercepts. Again, go back to our flip book where we wrote that down. If discriminant is 0, there is 1 x-intercept. If discriminant is positive, there are 2. If discriminant is negative, there are no real intercepts. So we'll see if our next practice problem can model the solution we'll have if we have a negative discriminant.